Thank you so much for having us. Yeah, we're delighted to be able to share some of our work around AI and how vector search is plugging into that. Aaron and I will give a quick overview of this space and the product that we've been working on. And then Kaz is going to show you the power of vector search in action. He's got a couple amazing demos ready to show you. So by way of like very quick introduction to vector search, it's really built for low latency kind of online applications. And in general, the most kinds of popular applications we see out there are recommendation and semantic search apps. We also see a range of use cases around image classification and image search. And really, the things that are becoming most popular over the past year or two are chatbots and RAG applications. And so we increasingly see vector search being used for these kinds of Gen AI use cases. There are a number of other applications we see out there, things like deduplication. But fundamentally, vector search, the thing it's really good at is very quick retrieval of similar items. Kaz will show you some of these demos live in a second. But fundamentally, what vector search is doing is it's basically using a query, expanding a query to find related queries around it. And then in this example, surfacing images that are most relevant to those kinds of queries. So you'll see how Kaz actually built these demos in a second. But fundamentally, all of this is happening extremely quickly, and it's powered by vector search, which we position to be very highly performant and scalable. Just to dig into a little bit into the generative AI application, really around RAG here, this is an increasingly popular use case for developers and for enterprises. And vector search effectively ends up acting as the companion to these large language models. I'm sure, as a lot of you know, LLMs have a tendency to hallucinate and are fundamentally restricted to only being trained on certain types of data. And so RAG, at the end of the day, solves this knowledge gap for these large models. And so if you are a developer or an enterprise developer and you're building a business application that's grounded on your data, this is where vector search is a really great fit. It's for customers that are looking to augment the generated responses from the model with their actual business data. And so this is what it does. It grounds the responses in the business data itself. And this is really one of the emerging patterns that we see for vector databases as a whole, is being able to augment these responses with relevant results. When it comes to our implementation of vector search, we use SCAN. And so SCAN is an implementation of approximate nearest neighbor, which you'll probably hear about as you explore further the vector database space. SCAN was developed internally at Google initially and has been used across a range of Google apps. Think of like Search, Play, YouTube, and all of these are really built for those kinds of high performance scenarios that are out there. And so fundamentally, we're sharing this technology that's been built, again, for these very fast, scalable online search applications, which now a lot of developers and enterprises are eager to use. So let me hand it over to Aaron now to talk about our implementation, about vector search in particular, about some of its features and where we've been investing. Aaron?
Yeah, thanks, Greg, and thank you all for having us. It's great to be here with you virtually. So Greg talked a little bit about the background and the technology and what is it used for and some of the use cases. I'll talk a little bit about the capabilities that we offer with Vertex AI Vector Search. So uppercase vector search, not vector search, lowercase the capability. And our implementation, as Greg was talking about, is really built for fast retrieval. And you want that. If you're building an application that is serving users, Kaz will show some examples soon, you want that retrieval to be very quick. And Vertex AI Vector Search does that. It's extremely fast. And then it's also highly scalable. So as your application grows, you want that fast retrieval to be maintained. You want that low latency, low digit millisecond retrieval to be maintained. Vertex AI Vector Search is built to scale, and it's a managed service. So you don't have to worry about infrastructure. It auto scales to match your traffic, to match your data size, to match your growth. It's easy to use. So you don't want to be, managing infrastructure. You also don't want to be writing too much code. So we've made it fairly easy to use with a simple SDK. There's a console experience. So it just makes it easier to get started and get up and running. Because we're using Scan, which is our internally developed library, you also actually get very high quality, right? We talked a lot about performance, but what's also important is the quality of your results. So your results come back with very high recall, and it is cost effective. So it not only scales up, it does so very cost effectively because this library was developed for scale. We want to make sure that you're using the right amount of compute. And the way we have seen our product scale versus others is that it is extremely cost effective at scale. And then there's retrieval capabilities. So anyone here who's worked on information retrieval or search engines, there are more things you need beyond simpler retrieval. You want to be able to incrementally index. You want to be able to filter. You may want to use some diversity capabilities on your results. All of those are built into vector search. And then finally, we recently launched what's called hybrid search. And hybrid search basically gives you improvement on your relevance, where you are blending semantic retrieval with traditional keyword-based retrieval. Semantic retrieval is excellent, and it is leaps and bounds better than keyword retrieval in many cases. But sometimes you just want to match on a specific keyword. If it's a product catalog ID or a document ID that you just want to retrieve, or something that the model, the LLM, was not trained on, that is where keyword search becomes very powerful. And hybrid search enables you to retrieve both types of results within the same index in a managed way. So you don't have to worry about managing two different indexes. It's all within one index, gives you high quality. So to summarize, it's fast, it's scalable, high quality, cost effective, and has all the retrieval capabilities that you need. Some of the things we've been doing the past 12 months. So we're continuously improving our product. We've launched a bunch of new features. We've improved our filtering capabilities. Hybrid search, I just mentioned, is now in public preview, going to general availability by the end of this year. Developer experience has been a huge area of focus for us. So the console experience we launched, we've made it much faster to get started by creating an index in under 1 minute. We've improved our SDK, and we are continuously improving documentation just to make it easier to get up and running. Enterprise, if you're building enterprise-grade software, you need that security and that private cloud capabilities. All of those have been included and launched. And then we have integrations with common frameworks. So if you have been experimenting with RAG, Llama Index and LangChain are two very popular frameworks to do that. We have integrations with those. So we meet you where you are in your framework. Vector search is integrated there. GenKit is another one, a Google framework for AI applications where vector search has an integration. Lots more to come on all of these areas. We're continuing to improve and launch additional capabilities. To show one customer example, so this is from a recent blog post that was written by eBay. eBay, as people know, is a fairly large customer, has a fairly large catalog. They were looking for a solution that could scale and serve their recommendations. So when you browse eBay, you may see product recommendations based on your browsing history, based on the products that eBay thinks are relevant to the user. They needed a system that they could use very quickly, very low latency, and enable them to focus on building models and not, managing infrastructure. They transitioned to Vertex Vector Search, and it helped them, to quote, iterate 4 times faster and hit a latency of 4 milliseconds, which I think is pretty good. So this is one example of the use case and the types of customers that have been benefiting from Vertex Vector Search. And then lastly, just to zoom out, so vector search is one component that you would need if you are building a search or retrieval augmented generation application. You're going to need an embeddings. You're going to need an embeddings model. You're going to need a document processor. Maybe you want to use a generation of summary. We have all those as part of Vertex AI. So it's not just vector search. Once your results are returned, you would want to re-rank them with a more capable ranker. You would want to generate a summary. All of that is available on the Vertex AI platform, so you can build an end-to-end application all on our platform. And with that, I will pass it on to Kaz to actually show you what this looks like.
Okay, thank you so much, Ewan. Can you share my screen? Okay, yeah, thank you for that. So with rest of the like 15 minutes, I'd like to share a couple of interesting demos based on the vector search. So the first demo is this demo, the Vertex AI multimodal embeddings plus vector search demo. This is an integration of the two products. One is the embeddings API that allows you to upload text or images or the video to generate an embeddings from it without any effort for training your own embeddings model or the deep learning models from scratch. So and also the product is we are using is the vector search. So this is a very simple demo. So actually we just used written a few lines of the code to call the multimodal embeddings API to generate the embeddings for the images, product images, and then put the embeddings into the vector search. So you don't have to build the entire MLOps setups to produce this kind of the demo or product. So for example, you can choose any couple of different data sets from this demo site, but I'm now choosing the Mercari text-to-image data set. Mercari is one of the most popular selling app, just like eBay. They are retail customer, and they are selling they are providing the selling app for the used second-hand items, just like Etsy or the eBay. And now we have imported about 6 million or 5 million or 6 million the item images from the real Mercari, the real world the item database, and they generate the multimodal embeddings from those millions of the items, and then build the index with the vector search. So you can make any multimodal semantic query on this demo. For example, what is that? Cups with dancing people. Whenever you type any text query on that text will be converted into the multimodal embeddings that will be sent to the vector search to find the similar images that shares the similar semantics with the query. So you see all the cups with the dancing the people on the item images. And please note that we are not using any of the metadata like product item the titles or item descriptions for this search. We are not using any keyword search or metadata search for this. Because our multimodal embeddings model can understand, just like the Gemini, the LLM model, the embeddings model is smart enough to understand, oh, this is a cup, these are the cups, and those are the people dancing on the surface of the cups. So the model is smart enough to understand semantics, just like humans. So that's the reason why you don't have to put any tags or labels or categories, just like the dancing people cap kind of the tags is not necessary to build this kind of the recommendation or search systems. So that means you can throw any arbitrary semantic query like a shirts with dancing people, and you see the latency to find those t-shirts images with the 6 million images, 6 million items. The vector search can find out the similar items to the text query within actually it only takes like 10 to 20 milliseconds. So you can do the similar things with the LLMs like a Gemini or the third party, the LLMs, but it would always takes like a few seconds at least, or maybe some seconds. But with the vector search, you can get the result within tens of milliseconds. Even with the millions or billions of the items. That's the reason why you can get the faster response with all the major Google services like a Google Search or YouTube video recommendations or Google Play, the mobile app recommendations. all major Google services are powered by these technologies. Embedding plus vector search is the key of the Google business. So let me quickly show how it works, how you can build a similar kind of the multimodal search. The thing is that with the embedding model, it has the so-called embedding space in the vector space. So that has the that takes the any images or the text or videos clustered into the smaller space where each images or text shares the same meanings, like the image of the people or image of the foods, image of the toys. So with that, you can put the text to find similar images, or you can put the images to find the similar text, or maybe even you can do the image similarity search from images to images. So that's the reason why you can do the semantic search across the multimodality like a text or audio images. So that was the one interesting use case of the vector search. What I'd like to share is the hybrid search. So maybe you can use the embedding multimodal embeddings for this kind of the similarity search or image search, but that is not enough usually for building the production systems, because the end users and customers in many cases would like to use, for example, the product numbers or the very unique product names that has added yesterday. Those things is really hard to capture by the semantic search, because the semantic search is all about using the embeddings model, deep learning model, to understand the meaning of the queries or the items. So if the embedding model is not trained with those the newly added product names or product numbers, then the semantic search cannot work for finding those products with the product numbers or those things. So that's the reason why all the production, the search product systems like the Google search or the YouTube search are all built as the hybrid search systems. So for example, Google search is maybe one of the most popular hybrid search systems used by the billions of the people for last 15 years. Google search has introduced the semantic search capability back in 2015 and added to the existing keyword-based search of the Google search. So with that, so you can find the relevant documents or the web pages by the meaning or by the keywords. So that's the power of the hybrid search systems. And now the Vertex Search provides the hybrid search capability in it. So you don't have to build two different search engines, like a keyword search engine with Elasticsearch and the vector search with the Vertex Vector Search. Usually you have to build two different engines and merge the result. But with the hybrid search support on the vector search, it automatically merges those results from the keyword and semantics into as the single result from vector search. And it's super easy to use the hybrid search systems, so that you can just write tens of the lines of the Python code to get the embeddings for the semantic search and the embeddings for the keyword search, that is called sparse embeddings, and build the index, the hybrids for the hybrid search, and run a query with both the semantic embeddings, dense embeddings, and sparse embeddings, make a query. The result is that it's a merged result from both semantic search and the keyword search. If the result has both the highest scores for the both dense embeddings and sparse embeddings, the result will be shown at the top of the list. The result, like a kid's sunglasses, matches exactly with the query kids for the keyword search. So it ranked at the top. Whereas the result that matches with the only for example, the semantic search, like a classic USD, doesn't include the kid keyword, but it's similar for its meaning. USD could be similar to the kids, so that it will be ranked in the middle of the whole the search result from the vector search. So with the hybrid search support of the vector search, you can easily build a production hybrid search system by yourself by using the vector search. So that was the one things I really wanted to share. You can go to the GitHub repository and search with the generative AI and find the Google Gen AI repository so that you can find this hybrid search sample code and try it by yourself. And the last demo I really wanted to share is the generative recommendation demonstration. Let me explain the context behind the generative recommendations. Many people are building the chatbots or RAG systems that uses the Gen AI. But actually, the generating the text output from the chatbot is not the only applications the Gen AI is capable of. The majority of the gigantic, enormous number of the parameters in the LLM is used for actually a reasoning part. 80% of the parameters of the LLM is used for reasoning, not for the understanding or generating text. So in coming like 5 years, we'll be seeing more and more non-text chatbot kind of the non-generating use cases for the Gen AI. The one promising use cases is the recommendation, because the LLM like Gemini has the intelligence like humans, like the human shop staffs in the fashion items shops, right? So just like the human shop staffs, we can let the Gemini think about what would be the best query to generate to find the relevant the fashion items for these particular customers based on the requests or query from the customers or personalization history of the customer. That's the power of the reasoning you can use. For example, if the Gemini can get the query from the user looking for the warm clothes for the winter, not just throwing the warm winter clothes to the vector search or the search engines, but you can use the Gemini to expand the query or generate the tens of the different possible queries for the semantic search to find out the relevant items for the different the scenarios, like a type specific scenario, activity specific, or style specific. For example, if the customers like to do some winter sport, maybe you can generate a query for skiing or maybe running in the winter. Or if the customer is looking for any fashionable items with some European style or something, you can let the Gemini to generate the semantic search queries for the style specific, like a cashmere sweaters or puffer vest. So that's the power of the reasoning you can use. So this is the idea behind the generative recommendation. And I have created a short concept demo that proves the power of the recommendations, the generative recommendations. With these demos, I have typed the keyword hummingbird and with some prompt for the Gemini. So instead of use the hummingbird as the query for the semantic search, we let the Gemini to expand the query based on the different scenarios of the hummingbird, because the Gemini knows what hummingbird is and what is the habitat, or what is the profile, or what is the great acrobatic way of flying, that kind of things, so that we can let the Gemini to generate a very photogenic queries for finding the photogenic scenes for those animals like elephants, as you can see. It's almost impossible for having the end customers to generate these very creative kind of the semantic queries from scratch. So instead, we can use the Gemini to expand the queries in a very creative way. And we have built an actual demonstration called Infinite Nature based on this idea. This demo was exhibited at the last Google Cloud Next and also Google I/O. So if you type the query like penguin, then now behind the scene, it uses the Gemini to generate the tens of the different semantic the queries that is thrown to the vector search with the 6 million images of the animals. So you are seeing the result. So you'll be seeing the photograph of the penguins, different penguins, like chicken penguins, or I don't know what's the name of the penguins, but there'll be, it's not working well, maybe. Oh, It's not working well. Let me report this side. Let me try out Penguin. So that, yeah, actually, I can show the how kind of the queries they are generating. So this demo has the real-time, the log console on the UI. So you can check out the photo steps too. So check out the semantic queries the Gemini is throwing to the vector search. So we have the Penguin. And if you click one of them, it uses the standard RAG technologies to refer to the Wikipedia pages for the Penguin to generate the fun facts about the Penguin. So it reduces the risk of the hallucinations. It looks like we are seeing some latency on the demos. Sorry about that. But the thing is that it's working slowly for today. But you can see all the other the possible queries that is expanded by the Gemini tool. So if the customer is interested in the Penguin, maybe the customer could be also interested in the other possibilities, like the animals that swims underwater. And then it can also generate a bunch of the different semantic queries around the scenario. So with that capability, so now the customers don't have to type a lengthy prompt or queries for searching the relevant items or the animals or the fashion items anymore. You can just let the customers clicking those buttons to choose the interesting directions or possibilities of all the different scenarios. So that will be the scenario where you can get the power of the reasoning from the generative AI and the large language model in the future. And vector search is the core component that enables the whole experience of this kind of the project experiment. So that was the demos I wanted to share. Thank you.